Dilations. It's our final transformation that we're going to be talking about here. With dilations, the other transformations that we've talked about thus far, translations, reflections, and rotations, those are all known as rigid transformations. And the word rigid transformation refers to the fact that we are keeping the size of the figure the same. All we're doing is just changing position or direction when we're making those other transformations. But for dilations, the word is similar to, or it is the same word that's used when you go to the optometrist and they put the drops in your eyes to be able to make your pupil larger, to be able to get a better visualization of what's happening on the inside of your eye or back to your retina. So what happens when they dilate your eyes, your pupil increases in size. And so here for the definition of dilation, it's a transformation that changes the size of a figure. Dilations can either be made to the figure to make it larger, which we call enlarging, or just enlarge to make it larger, or reduce, which would mean to make it smaller. The amount that the figure will either be enlarged or reduced is affected by what's called the scale factor. So the scale factor is what determines whether it's going to be larger or smaller, and by how much. The scale factor is represented with the letter K as the chosen variable to represent the scale factor. No direct meaning as to why it's K. And if K happens to be greater than 1, it's going to become larger. And if K is between 0 and 1, so greater than 0 but less than 1, then the figure becomes smaller. As far as what it would look like if it was less than 0, that would be negative. And we'll look at that a little bit later. It's one of our conclusion questions as we look at a negative scale factor. And so the idea, the scale factor, what we're going to end up seeing is we're going to multiply the scale factor to the coordinates or the points that are part of the figure, or just the point, and that will cause it to either change in size, getting larger or smaller, and it's all based about the origin. And so really getting larger and smaller, but also getting reduced in towards the origin, or getting made further away from the origin, as we'll see. So it says to tell whether each scale factor here will stretch or shrink the figure. Stretch meaning enlarge, or shrink, reduce the figure. So with a K of 4.5, since that's greater than 1, we would expect it to enlarge. Or you could write the word stretch there, either way. K is equal to 1/2. Well, 1/2 is between 0 and 1, so that would be reduce. 7/5. Well, since 7 is greater than 5, 7 over 5 is going to be greater than 1 then, and so this would be enlarge. And a scale factor of 1.73 is greater than 1, so that would also be a scale factor that would enlarge the figure. So the only one in our list that reduced it was 1/2 there, because it's between 0 and 1. Steps to perform a dilation. So we're going to multiply all of the x and y values of the coordinates by a scale factor to determine the new coordinates. So both x and y are getting multiplied by the scale factor, and we do that to all of the coordinates. Then we graph the image using the new coordinates and label, as we've been doing with the proper prime notation. So for this first set, we don't have the graph, but we're just going to make a dilation on the coordinates themselves. So find the coordinates of each of the given transformations. So first we have a dilation of 2.5. So this 2.5 here that we're being told, that's k. So that's the scale factor that we're going to use. And so for each of our points, all of the x and the y values, we're just going to multiply by that scale factor of 2.5. So m prime then, if m was at 1, 0, m prime, 1 times 2.5 is just going to make 2.5. 0 times 2.5, still 0. So m prime would be at 2.5, 0. R prime is going to be negative 2 times 2.5, and so that should give us negative 5. And then negative 4 times 2.5 should give us 10. Yeah, negative 10. C prime, negative 1 times 2.5 is negative 2.5, comma, negative 3 times 2.5 is negative 7.5. Running out of room here, go down below. O prime, 6 times 2.5 is 15, and another 4, which would give us 10. Okay, so just taking the scale factor, multiplying it by all of the x and the y values to determine where the new points will end up. And if you notice, since this is a scale factor of 2.5, it should be making an enlargement. And if you notice our numbers, all except for 0, they all got larger in value, which would take them further out away from the origin and therefore making the overall figure larger. Okay, again, a dilation now, this time of 0.25. So 0.25 is our scale factor. 0.25 as a fraction is 1/4. So what we're really doing here is multiplying all of our numbers by 1/4. And if you look across our numbers here real quick, you'll notice that it's going to be nice because all of our numbers are multiples of 4, which when we multiply them by 1/4, that's the same thing as dividing by 4. The only one that's not, well, I guess 0 and negative 1 there. So we can pretty easily multiply by those, though. So 0 times 0.25, again, it's still just going to be 0. 0.25 times 4, though, so that's 1/4 times 4. And again, multiplying by 1/4, same thing as dividing by 4. So that's just going to result in 1. C prime, negative 1 times 0.25 would give us 0, or negative 0.25. And then 8, again, times 1/4, or divided by 4 would give us 2. And then H prime, negative 4 divided by 4 is negative 1, and 12 divided by 4 is 3. Okay, so that's where those new points would end up after making those dilations. In the column questions here, number 1, list 3 scale factors that will increase the size of a figure. So, 3 scale factors, or k values, that would increase the size of the figure. You can pretty much put anything here as long as it's a number that is greater than 1. So 2 would do that, 10 would do that, 1,500 would do that. So any number you could put there that's greater than 1. You could also have decimals, fractions, any of those types of scale factors as well. Then 3 scale factors that would reduce the size of the figure, or decrease it, and to do that we need scale factors that are between 0 and 1. So if I have something like 1/2, that'll do that. 1/4 or 0.25 like we saw will do that. Any fraction that has a smaller numerator than denominator is between 0 and 1, so that would do that. So something like 5/8 would make it also reduce. Okay, now this time not only using the scale factor to make the enlargement or the reduction with the dilation, but now also graphing our image. So just like we did yesterday for rotations, I'm going to make a little object and image chart over here so that I can identify where my coordinates are starting, what their values are, make the dilation, and then be able to plot my new ones. So we've got Q, looks like X, N, and can't have two N's, so this one down here must actually be an I. Yeah, it's an I with the arrow next to it. So we've got N over here and then I at the bottom. Alright, so Q is at 0, 2. X is at 1, 2, 3, 4, -1. N is at -1, -3. And I is at 0, -5. Okay, so then the primes of each of those after I've applied the scale factor, this time it's by 0.5. So multiplying by 0.5 is the same thing as multiplying by 1/2, or that would be the same thing as dividing by 2. So I'm basically going to divide all of my x and y values by 2. Still going to be 0 for 0, but then 2 will become 1. 4 will become 2. -1 will become -0.5 or -1/2. -1 again, so -0.5 or -1/2. -3 becomes -1.5. 0 becomes 0, and -5 will be -2.5. Okay, now I can plot those new coordinates. So 0, 1 will be right there. That'll be Q prime. 2, and then -1/2 is halfway down to -1. And that'll be X prime. And N is -1/2, -1.5, so it's going to end up in the middle of a box here because they're both half units. And that'll be N prime. And then 0, -2.5 will be I prime. And so if I now go through and connect those, what I'm going to see is it makes a same type of figure, just reduced in size. If we go back to thinking about it a couple weeks ago when we were talking about congruent and similar figures, that would mean that these now are similar figures because all of the side lengths are actually going to be proportional to one another. So similar figures is what you end up with when you do dilations. All the other ones, the rigid transformations, translations, reflections, and rotations, those all make congruent figures. But after you do a dilation, you'll have a similar figure because it won't be the exact same, but it'll be proportional in the size. Okay, another one to do here, this time a dilation of 1.5. So if we think about that, it's greater than 1, so this should make an enlargement or make the figure larger after we do this. But again, start with our object and image chart. We've got an R, N, M, and an S. Okay, R is at 1, 2. N is at -1, 1. 1, -3 for M, and 2, 3, -3 for S. Okay, now multiplying all of those by 1.5, so R is going to become 1.5, 3 for R prime, -1.5, 1.5 for N prime, and then 1.5, -4.5, and then 4.5, -4.5. So a lot of half units in this one. Okay, so plotting those, we got R prime at 1.5 and then up to 3. negative 1.5 up to 1.5 for n prime. M prime is 1.5 down to negative 4.5. So get in the middle of a box here. And then 4.5, negative 4.5 for S prime. Connect those. And indeed, we enlarged our figure. So this was a dilation with a scale factor greater than 1, and it did make our figure larger. Okay, next up, writing the rule. So for dilations, we're always going to say dilation of. And now it's our job to figure out what the scale factor was. So there's a couple different ways we can figure out the scale factor. I can look at object and image coordinates. So like if I look at B here and compare that to B prime. So B was at 2, negative 2. And then B prime is at 3, negative 3. And so what I can say is that in order to make B prime, it's a 3:2 ratio is what the enlargement is there. Or I can also look at a side length in my figure and compare a side length. So here between E to B, I have 1, 2, 3, 4 units. And the E prime to B prime is 1, 2, 3, 4, 5, 6 units. So my scale factor is a 6:4 ratio. It increased to 6 over 4, but if I reduce that down, that's also going to make 3/2. So I can say that it's a dilation of 3/2, or that's the same thing as 1.5, so either way would work there. But that makes sense because it's a scale factor that's greater than 1, and my non-primes are the smaller figure, my primes are the bigger figure, so that means this was an enlargement. Okay, looking at that same idea here for number 6. Again, I can tell it's a dilation because we have a size change that happened here. So dilation of, and again, if I either compare a set of coordinates, the only one I can't use here is D and D prime because they're both at 0, 0, and so that's not going to show me what happened with the difference in the scale factor. But if I do something like U, it went from U was at 4, 0, and then U prime is at 1, 0. This time, the U prime of 1 to 4, it's a reduction, and so I can see that it needs to be a scale factor that it's between 0 and 1, or if I also look at the side length, so the side length between D to U is 1, 2, 3, 4 units. The side length between D prime to U prime is only 1 unit. So it went from 4 down to 1, so that again, that's a reduction of 1/4, or that's the same as 0.25. Okay, for number 7, writing the rule for each given dilation. This time, though, I don't have the graph to look at. All I have is just the figures. But T went from 4, negative 4 to T prime, which is at 2, negative 2. W went from 6, 8 to 3, 4. And then O went from negative 2, 1 to negative 1, 0.5. So if I think about what's happening each time, my numbers, they're getting smaller, and it's by a factor of 2. So we're dividing by 2 here. So this is a dilation of, and I don't want to put 2 though because they were getting smaller. So in order for them to get smaller, we have to be dividing by 2 in order to make that happen. But that means multiplying by 1/2. So dilation of 1/2, or I could say 0.5 would work there as well. Again, I see that a dilation's happened because it's the same factor that's affected all of my points. Okay. In the conclusions now. So, We have Luis is dilating a triangle ABC below. He multiplied each x and y coordinate by a scale factor of -2. So what are the coordinates of the object and image? So we'll do object here on the top because that's our non-primes. Image is down here on the bottom. So for the A is at -3, comma 2. B is at -2, -2. And C is at 1, comma 2. And now if I were to apply a scale factor of -2 to that, so here's where I said we would figure out what happens if the scale factor is negative. Well, if I multiply -3 times -2, that's going to make a +6. 2 times -2 is going to make a -4. -2 times -2 is +4, and same thing here. And then -2 comma -4 will be for C prime. If I now plot the image, so 6, -4, it's going to take me off the graph here a little bit. It's okay, I'll just kind of estimate where that's going to be at. So this is going to be A prime. B is going to be at, or B prime is going to be at 4, 4. And C prime is going to be at -2, -4. Okay, and if I go through and connect that now, okay, and if I look at what happened or what was done, so this image did get larger, but also what happened? Well, it flipped over. So describe how triangle ABC changed with a scale factor. It enlarged and was flipped over. So that's how the negative part of things affects things. So you'll still have enlargements and reductions, and it's basically beyond -1. Anything smaller than -1 is going to cause it to actually enlarge, but it's also going to cause it to flip over. And if it's between 0 and -1, so like -0.5, it'll get smaller, but it'll also flip over. Okay, conclusion question number 2. So what happens in the dilation when the scale factor is 1/2? So we know that that means that it will reduce the figure, because that's a scale factor between 0 and 1. So the figure is reduced. The scale factor is 1. Well, we didn't practice any of those, but if you think about it, multiplying all of the values by 1 will just keep them the same. So if the scale factor is exactly 1, the figure stays the same. A scale factor of 3 is greater than 1, so that will cause the figure to enlarge. The scale factor is -1. Well, it keeps its same size, but because of the fact that it's negative, it's going to cause it to flip over. So. The scale factor of -2, so that would be, as we just did up above, figure is enlarged, and flipped over, or better word to use there would probably be inverted, something like that. It's similar to rotating like 180 degrees as well. Okay, the summary today, I think I'm going to let you go ahead and just tackle that one on your own. So you're defining again what a dilation is, talking about scale factor. Scale factor of dilation can be determined by, so how to figure out what the scale factor is if you're trying to figure out how much the figure was enlarged or reduced, and then to perform a dilation, so explaining that. Okay, go find the worksheet for this that goes with it as well, and get that completed for today. And stay caught up for the week. Quiz will be out probably later tomorrow on Wednesday, and be ready to go with that.